So you would have heard about the terms like IQ data, right? In your from our previous sessions, we were talking about the what is IQ data. I mean, like there are some IQ data you plane messages that is getting changed between ODU and ORU, correct? Between ODU and ORU, we see there will be some user plane data, correct? First, there will be C plane data, then followed by user plane data, correct? So
Yeah.
the user plane data mainly consists of your IQ data, which is nothing but your actual data like voice or some up, upload or download of some videos or voice chart, all those things. All this data will be termed as IQ data in this communication perspective, okay, wireless communication perspective. So if you see this slide, right, I have uh, briefly gave details about the what is IQ data. Okay, so we start from basics of this wireless communication, right? Right.
IQ stand for
Yeah, I'll tell you that.
uh,
IQ stands for in phase and quadrature phase. Okay,
okay.
so if you see, so when you actually send some voice data, right, like any data from some person, okay, so when he speaks, it will be some voice data, okay, that will be converted into digital data using some sampling and all those things, correct? This will be generally whatever voice signal, it will be of unlocked data, correct? This will be converted into digital data, and this digital data will be represented as IQ data in terms during the modulation. So when this digital data goes into modulation, right? Uh, so when it goes to either QPSK, okay, VPSK, correct? You have COM, right? For 16 COM, 64 COM, 256 COM, right? All these are modulation techniques. So when this digital data is going into modulation phase, then the output will be called IQ data. Okay, so one IQ is nothing but in phase and Q phase. Okay, so in phase and Q phase is nothing but quadrature phase. So what does this mean? Like what is in phase and what is quadrature phase? So you are basically this whatever the output of this modulation, right, is basically defined in the uh, symbols. Okay, something like in phase and quadrature phase. Okay, so whenever you represent any symbol, right, that will be comprising of I component and also Q component. This will be generally a complex, like for example, 1 plus 1J, okay, is one IQ information, IQ symbol or IQ information, okay, or minus 1 plus 1J is another IQ symbol. So this one is nothing but your positive side, right? So that's why it is on positive quadrant. If it is minus 1 means this would be negative quadrant, like here. And similarly, minus 1 minus 1J will be here, something like this. Okay. This all constitute your IQ symbol data. Okay. So how this IQ data will be generated is basically using modulation techniques. Like, so if you go to some basics of modulation, right? You will be sending one amplitude, one in phase component amplitude and quadrature phase amplitude is being fed to IQ modulator with some carrier frequency, LO, local carrier frequency, and that will be resulted in this IQ data. Okay, that complete complex IQ symbol. So generally, I component will be called as cos wave. Okay, cosine wave, whereas Q will be called as sine wave. Okay, so if you want to represent in a the kind of waveforms. Okay, this will be the I component will be called as cosine wave, Q component will be called as sine wave. So both will be out of phase by 90 degrees. Okay, so I component and Q component will be out of phase by 90 degrees. So you can easily differentiate like what is I component and what is Q component. Okay, that is the idea behind this. So when you fed these signals to the modulator, right, it will give the resultant. I mean the combination of both I value and the Q value, which will be something like this: I plus Q value. It will be like a little bit phase shifted and amplitude increase in amplitude also you will see when both are combined. Okay. So generally the complete wireless communication, right, will only deal with processing of this IQ data. Okay. So that's why it's important to know about some details about the what is IQ data, what is how does it look like in real time. So all these graphs, right, will look like this. So if you see in a constellation view, right, it will be something like this. For example, QPSK. QPSK will have two symbols, correct? So okay. So if it, sorry, I'll show you that. See, it will be QPSK will be like this. Okay, this is QPSK. So that means each point, right, will be represented by 2 bits. Each symbol, this each point is nothing but symbol, is represented by 2 bits. Here also you see 11100100. This is for QPSK. So each of this is called IQ sample. So this will be represented in a IQ format as well. And similarly, BPSK, you'll have only 1 bit per symbol. That's why you have only either 0 or 1. Similarly, 16 comments, 16 bits should be there. 16 symbols should be presented. So you see, there are the 16 symbols in this constellation complete. So similarly, 64 com will be 64 symbols. Then 256 com will be having 256 IQ symbols. Okay. So this is how practically you will be seeing IQ data, how it will represent. So in the left side diagram also, right, how this IQ will be by increasing the amplitude of the I component and Q component, you will see different waveforms. Okay. So any questions in this IQ data? Did you understand high level what is IQ data? You just need to visualize this as an kind of output of a modulation process, wherein you can process the this type of data to effectively communicate to the receiver side. Okay.
Yeah.
Okay. So I'll also show you how does it look like in a like this all will be IQ data. The I sample is the amplitude of the uh, particular cosine wave. Then Q sample it will be sine wave amplitude. So this all component is called IQ value. Okay, these two together will constitute to one IQ symbol. Okay, it will be something like this. So for each PRB, you will see 12 samples of IQ data. Okay, so similar, for example, if you have 5 megahertz, okay, 5 megahertz bandwidth, you will see 25 PRBs. How it look. So let's go little more details about how this data transfer will happen during communication between ODU and ORU. So when it actually um, communicates between ODU and ORU, so you will see one is this is the DL path. Okay, the left side, this complete thing is called DL. This is DL procedure. This is UL procedure. Okay. So in case of DL, the control messages for uplane will be sent for slot n. For example, assume that slot n, there is a slot n. For that, there is a C-plane messages are being sent from DU to RU. So for now, you forget about this network delay. What is this TCP time advance? All those things. Okay, we'll cover that in our next topic. So for now, you ignore these parameters. You just assume, think that the C-plane messages will be reaching to RU after some network delay, because ORU and ODU will be connected by some um, Fronthaul interface, right? There will be delay associated with these two, correct? So that is called network delay. So we'll assume what type of network delay parameters are there. What is this TCP advance? Okay, all those things. So from here, you see control plane messages are arrived to ORU, then followed by U plane for the symbols. For example, there is a till slot in the C plane messages have been sent. Okay, then the respective U plane data for all those slots will be sent. Okay, so for slot n symbol 0, slot n symbol 1, slot n symbol n minus 1. For example, there are 14 symbols in slot n. Then all those 14 symbols information will be sent for that particular from DU to R. Similarly, for the next subsequent slot, slot n plus 1, there will be similarly slot n plus 1, 14 symbols will be sent to from DU to R in case of downlink. Okay. So if you